On the morning of October 29th, 2025, the world woke up as it always did. It woke up to the sound of noise. In New York, the subway trains rattled underneath the pavement, carrying millions of people who were already tired before their day began. In Tokyo, the neon signs flickered against the early grey sky, competing with the bright screens of smartphones held in every hand. In London, coffee machines hissed in busy cafes, drowning out the sound of the rain. The entire planet was a symphony of electronic beeps, car horns, and the endless chatter of voices. If you looked at the trending topics on social media that morning, you would see the usual things. People were arguing about a new tax law. A famous pop singer had just broken up with her boyfriend. A cat video was going viral because the cat looked like it was dancing. This was the reality for 8 billion people. Their eyes were locked on the screens in front of them, scrolling through a digital world that felt incredibly important yet was completely small. They had no idea that the most important thing in the solar system was happening right above their heads. It was happening exactly 203 million kilometers away. To understand this distance, you have to leave the noise of Earth behind. You have to travel past the moon, past the silence of the satellite belt, and into the deep cold dark. Out here, there is no air to carry sound. There are no headlines. There are no opinions. There is only the absolute freezing vacuum and the laws of physics. Here in this vast emptiness, the object known as 3I Atlas was moving. It was not a monster, it was not an alien warship, it was a rock or perhaps a dirty snowball older than the mountains on Earth. It was an interstellar traveller, a visitor that had been kicked out of its own home system billions of years ago. It had drifted through the darkness between stars for eons, silent and invisible, until gravity pulled it toward our sun. On this specific day, October 29th, 3I Atlas was reaching a critical point in its journey. It was cutting through the darkness at a speed of 44 kilometers per second. That is fast enough to travel around the entire Earth in just over 15 minutes. Yet to a human observer, it would look like it was standing still if they could see it at all. But they could not see it, and that was the great irony of this day. Down on Earth, the few news channels that actually mentioned 3I Atlas got it completely wrong. They wanted drama, they wanted fear. The headlines on the internet shouted things like, "The Doomsday Rock," or "The Visitor from Hell." They used computer-generated images of burning rocks crashing into cities. They interviewed experts who were not really scientists, people who waved their hands and spoke about secret government cover-ups or ancient prophecies. They made the public think that if they looked up at the sky, they would see a giant streak of fire, like a second moon glowing red. The reality was much quieter and much more disappointing to the average person. Atlas was invisible to the naked eye. It was simply too small and too far away. Even though 203 million kilometers is considered close in astronomical terms, it is still a distance that the human brain struggles to comprehend. It is more than 1.3 astronomical units away, 1.3 times the distance between the Earth and the Sun. At that range, a rock that is only a few hundred meters wide reflects almost no sunlight. If you stood in the middle of the Sahara Desert on that night far away from the city lights and looked up at the perfect spot in the constellation of Pegasus, you would see nothing. Just the same stars that had been there for thousands of years. To see 3I Atlas, you needed more than eyes. You needed a telescope with a mirror the size of a dinner table. You needed sensitive digital cameras that could capture light over several hours, and even then the image you would get was not a fiery dragon. It was a faint fuzzy grey smudge, a tiny dot barely distinguishable from the background noise of the universe. This is what made the event so isolating for the few people who truly understood it. Imagine being one of the few astronomers sitting in a high-altitude observatory in Chile or Hawaii on that night. The room is cold and dark, lit only by the red glow of computer monitors. You are watching the data stream in. You see the numbers, the coordinates, the velocity, the spectral analysis. You know that you are looking at something that has travelled from another star system. You are witnessing a visitor that will pass by and then leave never to return. It will continue its journey back into the interstellar night, exiting our solar system and drifting for another billion years. You feel a sense of awe that makes your chest tight. You feel small. You feel a connection to the deep history of the galaxy. Then you pick up your phone. You open a news app. You see a headline, "Will the mystery comet hit Paris? Click here to find out." The contrast is enough to make you laugh, but it is a tired, cynical laugh. The world was obsessed with a fantasy version of the event, while the real event, the beautiful, silent, mathematical precision of it, was ignored. The media turned the universe into a movie script. They wanted noise. They wanted explosions. They could not sell silence. They could not sell the idea that something can be massive and important without affecting the price of gas or the result of a football game. So on October 29th, the separation was complete. On one side there was humanity, loud, chaotic, worried about tomorrow's weather, obsessed with themselves, trapped in a bubble of information that was mostly nonsense. On the other side there was 3i Atlas, a silent ghost. It did not care about our headlines, it did not care about our fears. It obeyed only the curve of space-time. It spun slowly in the void, its surface temperature hovering near absolute zero, minus 273 degrees Celsius. It was a piece of history from a time before Earth even existed, gliding past us like a ship passing an island in the night, keeping its lights off. For those of us who knew the truth, the insiders, the observers, the ones who respected the silence, this day felt like a secret. We walked through the crowded streets, surrounded by people shouting into their phones, and we looked up at the blue sky. We knew it was there. We knew that right now, at this very second, the visitor was making its closest approach. We felt a strange sense of loneliness, but also a sense of privilege. Let the world have its noise. Let them have their panic and their viral videos. We had the truth. We had the silence. And in that series, as the Earth spun on its axis and the clocks ticked toward noon, 3i Atlas continued its lonely voyage, slipping through the gap between the planets, unseen, unheard, and utterly magnificent. As the object known as 3i Atlas falls deeper into the gravity well of our star, the velvet blackness of space is replaced by a blinding, all-consuming white. We have entered the cosmic crucible. This is the approach to Perihelion, the point in an orbit where a celestial body comes closest to the Sun. It is not merely a location on a map, it is a physical state of violence, a place where the laws of physics are tested to their absolute breaking point. Here, the silent vacuum of space becomes a roaring furnace of radiation and light. To understand the terror of this region, one must first understand the sheer weight of the energy involved. Imagine a heater with the power of 770 watts focusing all its energy onto a single square meter of space. Now imagine that energy is not just heat, but a physical punch. This is the relentless intensity that 3i Atlas must endure. Unlike the gentle warmth we feel on a summer day on Earth, the sunlight here is a weapon. It does not just warm the surface, it hammers against it. At this distance, the sun is no longer a friendly yellow circle in the sky. It is a wall of fire that stretches across the entire field of view, a monstrous ocean of plasma that breathes and pulses. The temperature begins to climb not in degrees, but in leaps of destruction. It rises hundreds, then thousands of degrees. This is the environment where solid matter screams. For a natural object, this heat is a sentence of death. Consider the physics of a standard comet, a dirty snowball made of ancient ice dust and rock. When a natural comet approaches perihelion, it undergoes a violent, chaotic transformation. The heat does not melt the ice into water. The pressure is too low for that. Instead, the ice instantly transforms from a solid frozen block into a gas, a process called sublimation. It is explosive. The crust of the comet cracks open with the sound of gunshot-like ruptures. Jets of steam and dust blast outward, creating the long, beautiful tail we see from Earth. But up close it is not beautiful, it is a catastrophe. The comet is bleeding its mass away. It is being eaten alive by the heat. It spins wildly as jets of gas push it in random directions, tumbling like a dying leaf in a hurricane. However, 3i Atlas behaves differently, and this is where the acid test begins. This is the ultimate examination for any object entering the inner solar system. The acid test asks a simple question: are you a rock or are you a machine? Under the glare of 770 watts per square meter, the distinction becomes undeniable. While a natural comet would be shedding layers of skin surrounded by a chaotic cloud of its own debris, 3i. Our Atlas remains terrifyingly clean. There is no halo of dust, there are no explosive jets of gas. Under the hypnotic, shimmering waves of heat, the surface of 3i Atlas does not crack. It reflects. Here we witness the war between two titanic forces, gravity and radiation pressure. Gravity is the greedy hand of the sun. It grabs the object, pulling it inward with incredible speed, trying to drag it into the fiery surface to be consumed. It is a force of attraction, heavy and crushing. For a natural rock, gravity usually wins, swinging it around in a stressed curve. But then there is radiation pressure. Light, we must remember, has mass in the form of momentum. When billions of photons, particles of light strike a surface, they push back. It is a wind made of pure brightness. For a heavy rock, this pressure is like a mosquito hitting a truck. It creates no difference. But 3i Atlas is different. It is incredibly light for its size and its shape is vast and flat. As 3i Atlas dives into the furnace, the light does not just heat it, the light lifts it. The radiation pressure pushes against the object with a force that rivals the pull of gravity. It is a silent, invisible tug of war. The sun tries to pull it in, but the light of the sun tries to push it away. A natural object would ignore this push, but 3i Atlas rides it. It treats the lethal radiation not as a hazard, but as a fuel source. The way it moves through the perihelion is smooth, controlled, and eerie. It does not tumble. It stabilizes itself, turning its face into the solar wind like a sail catching a breeze. The heat continues to rise. The energy beating down on the surface is enough to melt lead, enough to boil aluminum. If 3i Atlas were made of stone, it would fracture from thermal shock. If it were made of common metal, it would warp and buckle. But it holds its shape. The material glows, perhaps shifting in color as it dissipates the thermal load, but it does not yield. It absorbs the punishment with a mechanical indifference. This passage through perihelion is slow, mesmerizing, and terrifying. Time seems to stretch. The object skims the surface of the star, dancing on the edge of destruction. Every second it survives in this hellscape confirms its artificial nature. A natural comet is a victim of the sun. 3i Atlas is a challenger. The intensity of 770 watts per square meter acts as a sieve separating the weak from the strong. Nature creates things that break under this pressure. Nature creates things that crumble, evaporate, and die when they fly too close to the flame. Only intelligence creates something that can stare into the eye of a star and not blink. As 3i Atlas reaches the point of closest approach, the tension is palpable. The gravitational forces are trying to tear it apart, pulling the front of the object harder than the back. The thermal expansion is trying to rip its structure to pieces. The radiation is hammering it with the force of a physical blow, and yet it glides. It cuts through the corona to the sun's outer atmosphere like a knife through hot water. It is a silent survivor in a realm of noise and fire. The acid test is complete. The rock would have died. The machine has survived. As it begins to curve away, leaving the point of maximum heat behind it, carries the scars of the journey, but its trajectory has changed. It has used the fire to speed up. It has used the danger to gain power. It rises from the cosmic crucible not as a pile of dust, but as a traveller who has conquered the fire. To understand how we captured the full fury of this solar storm, we must look away from Earth. If we only stood on our own planet and looked up, we would be like a person trying to watch a baseball game through a keyhole. We might see the ball coming at us, but we would miss the pitcher's winding motion, the position of the outfielders, and the curve of the throw. To truly see the sun, we needed a team. We needed eyes scattered across the solar system. Humanity has built a web of eyes. It is a silent mechanical army stationed in the void, keeping an eternal vigil. These are not just machines, they are our sentinels. They are robotic guardians that float in the freezing darkness so that we can understand the fire. The sentinels at the red planet. First, let us cast our minds outward to Mars. While we were panicking about auroras and power grids on Earth, the solar storm did not stop at our planet. It continued rushing through the dark, striking Mars moments later. Here we find the Mars orbiters. Imagine them as the distant scouts of our army. Spacecraft like Maven and the Mars Express have been circling the red planet for years. They are lonely workers. They do not have the comfort of a thick atmosphere to protect them. When the solar storm hit Mars, these orbiters were hit with a wave of radiation and energy. But they stood their ground. They measured how the solar wind stripped away tiny bits of the Martian atmosphere. Because Mars was in a different position relative to the Sun compared to Earth, these orbiters gave us a side view of the explosion. They acted like a camera placed on the sideline of a football field, showing us the width and the speed of the storm in a way that the front-facing cameras never could. The diver and the veteran. Closest to the fire, we have the bravest of them all, the Parker solar probe. If the other spacecraft are guards, Parker is the daredevil. It is the first human-made object to touch the Sun. It dives through the outer atmosphere of the Sun, enduring heat that is hard to imagine. During this event, Parker was right in the thick of it. It was swimming upstream in the river of solar wind. It measured the magnetic particles before they even had a chance to cool down. It felt the blast at point-blank range. It sent back data that tasted of raw fire, telling us exactly how dense and fast the material was when it was born. Watching from a safer distance is the veteran SOHO Solar and Heliospheric Observatory. SOHO is like the wise old grandfather of solar observation. It has been staring at the Sun for decades. It uses a special instrument to create a false eclipse, blocking out the bright disk of the Sun, so it can see the faint ghostly atmosphere around it. SOHO saw the coronal mass ejection leave the cell. It saw the halo, a ring of gas expanding in all directions, which is the surest sign that a storm is heading straight for Earth. SOHO never blinks. It is the steady, reliable witness that confirms the danger before it arrives. The New Guardian goes 19. Then there is the new recruit standing guard right at our front door, goes 19. This satellite sits in a geostationary orbit, which means it hovers over the exact same spot on Earth, moving at the same speed as our planet's rotation. GOES 19 is special because it carries a new generation of compact instruments. Think of it as having a pair of high-definition binoculars compared to the blurry telescopes of the past. It monitors the X-rays and the extreme ultraviolet light that hit our upper atmosphere. When the storm arrived, GOES 19 was our first line of defense. It measured the immediate shock to Earth's magnetic field. It told the power grid operators, "It is here, and it is strong." It is the shield bearer taking the measurements that decide whether we need to shut down satellites or reroute airplanes. The long-distance traveller, JUICE, perhaps the most poetic member of this web, is JUICE, Jupiter Icy Moons Explorer. This spacecraft is on a long, lonely cruise to Jupiter. It is currently millions of kilometers away, drifting through the deep black. It was not designed specifically to warn Earth of solar storms. Its mission is to explore the frozen oceans of Jupiter's moons years from now. However, during this event, JUICE acted as a testament to the scale of the storm. Even across the vast distance of space, JUICE felt the ripple. Its sensors picked up the change in the magnetic environment. This is where the geometry of the situation becomes beautiful. Imagine the sun is a light bulb in the center of a dark room. Earth is a marble on the floor. Mars is a marble on a table. JUICE is a marble rolling near the door. By looking at the data from all these different points, scientists can build a three-dimensional shape of the explosion. If we only had Earth, we would think the solar storm was a flat wall hitting us. But because we have JUICE far away and Mars to the side and Parker up close, we can see that the storm is actually a giant expanding bubble. We can see its curvature. We can measure how it slows down as it travels deeper into space. The dance of orbital mechanics. This is the triumph of orbital mechanics. It is not just about shooting rockets up. It is about the elegant mathematics of placing them in the right spots. We place some satellites at a point called Lagrange point 1. This is a magical spot in gravity where the pull of the sun and the pull of the Earth cancel each other out perfectly. A satellite can park there, hovering between us and the star, constantly looking forward. This gives us a warning of about 15 to 45 minutes before the particles hit. Other spacecraft are in polar orbits circling over the top and bottom of the sun, seeing the poles that we can never see from the ground. It is a geometry of angles and curves. We calculate the Sun-Earth line. We measure the angle of separation between Mars and Earth. We use trigonometry to calculate the speed of the gas. It is a giant math problem solved by metal boxes floating in nothingness. A silent symphony. There is something deeply moving about this network. These machines are running on code written by humans, powered by sunlight, surviving in a vacuum where the temperature swings from boiling to freezing in seconds. They talk to each other, or rather they talk to the deep space network giant radio dishes on Earth that listen for their faint whispers. Parker screams its data across the inner solar system. JUICE hums its findings from the dark outer reaches. GOES 19 chatters constantly from high orbit. They are like a synchronized orchestra playing a symphony of data. There is no conductor waving a baton in real time. The distances are too great for that. Instead, they follow the instructions uploaded weeks or months ago. They perform their duties with absolute precision. When we look at the images of the sun, those swirling angry balls of orange and violet fire, we should remember how we got them. We got them because we built a web of eyes. We extended our senses. We cannot touch the sun, so we built Parker to touch it for us. We cannot stand on Mars to watch the storm pass, so we built Maven to stand there for us. In the silence of space amidst the deadly radiation and the cold, these machines are the noble extensions of human curiosity. They watch the dark so that we may live in the light. To understand the storm that was about to break in the scientific community, we must rewind the clock a few months. Let us go back to the quiet hum of the server rooms between July and October of 2025. This was the period of data collection, the calm before the intellectual violence. At that time, 3O Atlas was still just a ghost on our sensors, a faint point of light falling toward the inner solar system. But as the telescopes in Hawaii, Chile, and orbit began to feed their data into the central processing hubs, a dossier began to form. It wasn't a single photograph. It was a collection of 8 distinct impossibilities. Any one of these traits would have been a career-defining discovery for an astronomer. Finding all 8 in a single object was not just rare, it was terrifying. Here is the breakdown of the file that kept the world's smartest people awake at night. 1. The hyperbolic excess velocity. The first anomaly was the speed. When we find a rock in space, we calculate its orbit to see where it lives. Most objects trace an ellipse, meaning they orbit the Sun in a closed loop. 3i Atlas was different. It was tracing a hyperbola. It entered our system at a velocity of nearly 90 kilometers per second. To put that in perspective, it was moving far faster than any comet or asteroid born from our own solar nebula. It was not bound to the Sun. It was a drifter, a vagabond falling from the vast empty darkness between the stars. The math was absolute. This object was not from here. It had travelled for perhaps millions of years to reach us, and it had no intention of staying. 2. The impossible geometry. As 3i Atlas drew closer, we tried to resolve its shape using light curves. By measuring how the sunlight bouncing off the object changed over time, we could model its physical dimensions. The computer models crashed twice before giving us an answer that looked like a glitch. Natural space rocks are usually potato-shaped or spherical. 3i Atlas was neither. The data suggested an extreme aspect ratio of 10:1. Imagine a cigar, or more accurately a flattened shard or a needle. It was roughly 400 meters long but incredibly thin. Nature does not typically sculpt rocks into long, thin splinters because the forces of rotation and gravity usually break them apart. For an object to maintain this shape while tumbling through the void, it had to be made of something incredibly strong. 3. The chaotic tumble. Associated with its shape was its movement. It wasn't spinning around a clean axis like a football spiraling through the air. It was tumbling end over end in a chaotic, non-periodic rhythm. This tumbling suggested a violent history. It implied that something had hit it hard in the distant past, or that its internal weight distribution was uneven. It looked less like a celestial body and more like a derelict ship caught in a gravity well, spinning out of control. 4. Non-gravitational acceleration. This was the characteristic that caused the most arguments. As the object passed the orbit of Mars, it began to deviate from its predicted path. Gravity is the ruler of the cosmos. Its laws are strict. If you drop a ball, it falls. But 3i Atlas was not just falling, it was being pushed. We call this non-gravitational acceleration. In comets, this is normal. As a comet heats up ice, turns to gas, and shoots out acting like a tiny rocket thruster that pushes the comet slightly off course. We expected this, we looked for the gas. But that leads us to the next most maddening point. 5. The missing coma. If 3i Atlas was accelerating because of outgassing, we should have seen a coma, a cloud of dust and gas surrounding it. We pointed our most sensitive infrared cameras at it, looking for the heat signature of water vapor, carbon dioxide, or dust. We found nothing. The space around 3i Atlas was a perfect vacuum. There was no tail, no cloud, no evaporation. It was a dry, dead stone, yet it was speeding up. A dry rock does not accelerate on its own, unless it wasn't a rock, or unless the propulsion was coming from something we couldn't see with standard instruments. 6. The spectral anomaly. The nickel shell. When we analysed the light spectrum reflected off the surface to determine what it was made of, the results were monotonous. Usually asteroids are a mix of silicates, carbon, and various metals. 3i Atlas returned a signal that was shockingly pure. It showed strong absorption lines for nickel and iron with a distinct lack of rocky minerals. It resembled the core of a destroyed planet stripped of its crust. But the reading was too uniform across the entire surface. It looked less like a natural mixture and more like a coating. Some bold doctoral students whispered the word shielding in the break room, suggesting a metallic hull designed to withstand interstellar dust, but they were quickly silenced by their professors. 7. The anti-tail phenomenon. In late August, a deep space imaging probe caught a glimpse of something faint. Usually a comet's tail points away from the sun, pushed by the solar wind. 3i Atlas developed a short, sharp protrusion that pointed towards the sun. While anti-tails are a known optical illusion caused by viewing geometry in comets, this one persisted even as the viewing angle changed. It appeared to be a focused stream of particles, or perhaps energy directed sunward. It wasn't a passive trail of dust. It looked like an interaction. It pulsed rhythmically once every 8 hours, coinciding with the object's rotation. It looked for all the world like a vent. 8. The albedo paradox. Finally, there was the issue of brightness. We call the reflectivity of an object its albedo. Coal has a low albedo, snow has a high albedo. Based on its size, 3i Atlas should have been dim. Instead, it was 10 times shinier than the average asteroid. It reflected light almost as well as polished metal. However, despite absorbing very little sunlight, because it was reflecting so much, its surface temperature remained lower than expected. It was cold, too cold. This suggested that the object had a high thermal inertia, meaning it resisted changing temperature, or that it was made of a structure that dissipated heat incredibly efficiently. A shiny, cold metallic needle tumbling through the dark. Summary of the dossier. By the time October ended, the picture was complete yet entirely incomprehensible. We had an object entering our system at escape velocity shaped like a skyscraper made of pure nickel iron, tumbling chaotically, accelerating without fuel, and pointing a stream of particles at the sun, all while acting like a mirror. The data didn't fit the box labelled Comet. It didn't fit the box labelled asteroid. It was at this moment that the scientific community split into two warring camps. On one side were the naturalists desperate to find a geological model to explain these 8 coincidences. On the other side were the exoticists who began to draft papers with titles that would have been considered science fiction just a year prior. The dossier was closed. The debate was about to open. The morning of October the 29th arrived not with a bang, but with a quiet digitized stream of images. For weeks the world had held its breath. The internet was rife with speculation. Was 3i Atlas a messenger? Was it a probe? Or was it simply a wanderer? The answer did not come from a press conference at a podium, but from the silent, steady refresh rate of a satellite orbiting 1.5 million kilometers away from Earth. The truth when it arrived was absolute. It was delivered by the Solar and Heliospheric Observatory, known to astronomers simply as SOHO. Specifically, the data came from the LASCO C3 coronagraph, an instrument designed to block out the blinding glare of the sun, so that we can see the faint ghosts dancing around it. In the days leading up to this rendezvous, a Thai amateur astronomer named Warachi Boonplod had been meticulously tracking the object. Boonplod is a legend in the community of comet hunters. He does not look for spaceships, he looks for pixels that move against the background stars. His analysis was crucial because it was grounded in cold, hard numbers, not wishful thinking. While others were measuring the object's speed and wondering if it had an internal engine, Boonplod and the orbital dynamicists were calculating a trajectory that was terrifyingly precise. They saw an object that was not navigating, it was falling. On the 29th, 3i Atlas entered the field of view of SOHO. This was the moment of truth. If this were a manufactured craft, an alien probe visiting our system, this would be the moment it might adjust its course. It would be the moment it might shield itself from the thermal intensity of the sun, which at that distance is enough to melt steel and vaporize rock. We watched the feed waiting for a maneuver, we waiting for a signal. Instead, we saw the beautiful tragic obedience of nature. The object behaved exactly like what we call a sun grazer. As it approached the star, the intense gravitational pull accelerated it to speeds of hundreds of kilometers per second, but more importantly, the heat began to work on it. The data showed that 3i Atlas did not have a heat shield. It did not have a hull of exotic alloys. It was quite simply a dirty snowball. It was a mix of ancient ice-frozen gases and cosmic dust that had been bound together for billions of years in the dark cold of the outer system. When that ice met the fire of the sun, it did not fight back, it sublimated. This means the solid ice turned instantly into gas, skipping the liquid phase entirely. The brightness data was the final nail in the coffin of the alien theory. If 3i Atlas were a solid metallic ship, its brightness would have remained relatively steady or increased predictably as it reflected more sunlight. But the light curve, the graph showing how bright the object is over time, told a different story. It flared up brilliantly, a last gasp of glory, and then it began to fade rapidly before it even reached its closest point to the sun. This is the classic signature of a comet that is disintegrating. The nucleus, the heart of the comet, was breaking apart under the thermal stress. It was crumbling into a cloud of dust. The object ceased to be a single thing and became a scattering of particles, a ghost made of glowing gas. Spectroscopic analysis, which breaks light down to tell us what things are made of, confirmed the mundane reality. There were no signatures of refined titanium or artificial isotopes. Instead, the instruments detected the familiar fingerprints of our universe: hydrogen, carbon, oxygen, sodium. It was the same chemistry that makes up the water in our oceans and the carbon in our bodies. 3i Atlas was not a visitor from a civilization. It was a sample of the primordial soup from which our solar system was born. For those who had spent the month dreaming of first contact, the feeling was a gentle, heavy deflation. There was a specific kind of silence in the online forums and the chat rooms. The truth was not a government cover-up or a galactic federation. The truth was thermodynamics. The truth was that ice melts when it gets too close to a fire. However, for the astrophysicists and the astronomers, this was not a disappointment. It was a quiet victory. It was a triumph of prediction. We had used mathematics invented by Isaac Newton 300 years ago to predict the motion of a rock travelling through the void, and the rock had obeyed those laws to the fraction of a second. There is a profound beauty in this normality. The object was obedient. It followed the curvature of space-time exactly as Einstein predicted. It fell apart exactly as material science predicted. It proved that the laws of physics are universal. They apply here on Earth, and they apply to a wanderer coming from the deep dark. 3i Atlas did not need to be a spaceship to be miraculous. It was a time capsule from the dawn of creation, and it sacrificed itself to the sun in a display of natural splendor. The images from Soho showed a long, thin tail of white light that eventually just evaporated into the background noise of the solar wind. It was like watching a moth fly into a lantern flame. It was brief, it was bright, and then it was gone. As the date passed and the debris cloud dispersed into nothingness, the scientific community felt a deep sense of calm. We were not ready for aliens, perhaps, but we showed that we are very good at understanding the silent spinning clockwork of our own solar system. The failure to find life was matched by the success of understanding nature. 3i Atlas was gone. It did not send a radio message. It did not scan our oceans. It simply came from the cold, felt the warmth for the first time in eons, and returned its atoms to the star that governs us all. It was a normal day in the universe, and there is a great stabilizing comfort in knowing that the universe is still behaving exactly as it should. As the mysterious visitor known as Oumuamua tumbled away into the darkness of the outer solar system, it left behind more than just silence. It left a fracture in the scientific community. While many astronomers were content to classify the object as a strange asteroid or a peculiar comet, one voice rose above the rest, challenging us to look at the data with fresh eyes. This is the perspective of Professor Avi Loeb, a former chair of astronomy at Harvard University. His arguments force us to confront a question that makes many uncomfortable. What if we are not the only intelligent observers in the universe? The limitations of natural explanations. To understand why the debate exists, we must look at why standard explanations failed to satisfy everyone. The primary issue was not just one anomaly, but a collection of them. The most difficult puzzle piece was the movement of the object. As Oumuamua passed the sun, it accelerated. In the world of comets, this is normal. When a comet gets close to the sun, heat warms up the ice on its surface. This ice turns into gas and shoots out, acting like a natural rocket engine that pushes the comet faster. This is called the rocket effect. However, for this to happen, there must be a tail of gas and dust. The problem was that Oumuamua had no tail. Deep space telescopes looked for carbon-based gas, water, or dust, but they found nothing. It was a rocket without an exhaust pipe. Scientists tried to fit this into natural models. Some suggested it was a hydrogen iceberg, a chunk of frozen hydrogen that would turn into invisible gas. Others proposed a nitrogen iceberg chipped off a distant Pluto-like planet. Some even suggested it was a dust bunny, a giant fluffy collection of dust held together by weak forces. For Avi Loeb, these explanations felt forced. We have never seen a hydrogen iceberg. We have never seen a giant dust bunny survive the intense heat of the sun. To accept these theories, we have to invent entirely new types of natural objects that we have never observed before. Loeb argues that this requires just as much of a leap of faith as considering an artificial origin. If we have to invent new physics to explain a rock, perhaps we should consider that it might not be a rock at all. Getty images. The light sail hypothesis. Loeb proposed a different solution, one that fits the data without needing invisible comets. He suggested that Oumuamua might be artificial. Specifically, he looked at the acceleration. If it was not gas pushing the object, it might be the pressure of sunlight itself. Light has no mass, but it has energy and momentum. When sunlight hits a surface, it gives a very tiny push. For a massive rock, this push is too small to measure. But if an object is extremely thin, thinner than a sheet of paper and very wide, the pressure of sunlight is enough to push it forward. This technology is known as a light sail. We humans are already developing this technology. Projects like the Starshot Initiative aim to send tiny probes to other stars using powerful lasers to push light sails. If we are doing it, why assume a civilization a billion years older than us hasn't already done it? Loeb does not claim with 100% certainty that Oumuamua was a spaceship. Instead, he suggests it might be space trash. Imagine a plastic bottle washing up on a beach. A caveman might think it's a strange shiny stone. He has no concept of plastic or manufacturing. Loeb wonders if Oumuamua was simply a piece of defunct technology, a broken buoy or a piece of a wrecked station floating through the galactic ocean. The Galileo project shifting from opinion to data. Debating theories is useful, but science needs evidence. This is why the Galileo project was born. Instead of waiting for government reports on unidentified aerial phenomena UAP or arguing about blurry photos from decades ago, this project takes a proactive approach. The philosophy is simple, the sky is open to everyone. The Galileo project builds new telescope systems specifically designed to look for artificial objects near Earth. It uses artificial intelligence to filter out birds, balloons, and drones looking for anything that behaves in ways our technology cannot. This represents a shift in mindset. For a long time, looking for extraterrestrial technology was considered fringe or silly. It was a career killer for serious scientists. The Galileo project attempts to bring this search into the daylight of mainstream science. It operates on transparency, the data is open to the public, the analysis is peer-reviewed. It moves the conversation from "do you believe in aliens" to "let us look at the data together." The ostrich approach versus the open mind. One of the most profound aspects of this debate is psychological. Loeb often criticizes what he calls the ostrich effect. This is the tendency to bury our heads in the sand when we face data that challenges our worldview. If a scientist assumes that aliens do not exist, they will interpret every piece of data as a natural rock no matter how strange it looks. They will twist their theories into knots to avoid saying the word artificial. Loeb argues that this is not true science. True science involves following the evidence wherever it leads, even if it leads to a scary or uncomfortable conclusion. He uses the analogy of walking on a beach. Most of what you find are seashells and stones. These are natural, but every once in a while you might find a plastic bottle. If you have decided beforehand that plastic bottles do not exist, you will spend your whole life trying to explain how nature created a plastic bottle. You will miss the truth because you were not ready for the unexpected. The 30 or 40% probability. This brings us to the concept of betting on the unknown. When asked about the likelihood of Oumuamua being artificial, or the chances of the Galileo project finding something, Loeb does not say 0, and he does not say 100. He often speaks of a modest probability, perhaps 30 or 40%. This number is significant. It is not a certainty, but it is statistically huge. If you were told there was a 40% chance of rain, you would bring an umbrella. If there is a 40% chance that our solar system is filled with the debris of other civilizations, we should be building telescopes to look for it. This view challenges our ego. For centuries, humans believed the Earth was the center of the universe. Then we learned we orbit the sun. Then we learned the sun is just one of billions of stars. We keep finding out that we are not physically special. Loeb asks, why do we assume we are intellectually special? It is statistically likely that we are not the smartest kids on the block. We might just be a common civilization in a crowded neighborhood, but we have been too afraid to look out the window. Occam's razor and extraordinary evidence. Finally, we must look at the famous principle of Occam's razor. This principle states that the simplest explanation is usually the correct one. Critics use this to say aliens are complex, rocks are simple, therefore it is a rock. However, the definition of simple is tricky. Is it simpler to invent a hydrogen iceberg that defies the laws of thermal physics? Or is it simpler to assume that in a galaxy with billions of habitable planets, another civilization built a probe? There is a famous saying, extraordinary claims require extraordinary evidence. This is often used to shut down discussion about extraterrestrials, but Avi Loeb flips this script. He argues that extraordinary claims require extraordinary funding. We cannot find the evidence if we refuse to invest in looking for it. We spend billions on searching for dark matter, something we have never seen and do not fully understand. Why is searching for a technological neighbor considered too weird to fund? Conclusion, a humbling perspective. The interstellar debate is not about winning an argument. It is not about proving that Oumuamua was definitely a spaceship. It is about how we approach the unknown. It asks us to be humble. It asks us to admit that our knowledge of the universe is tiny compared to the vastness of space. Whether Oumuamua was a strange rock or a broken sail, it served a purpose. It woke us up. It reminded us that the universe is capable of surprises. If we keep our eyes on the ground, we will only see rocks. But if we are willing to be wrong, willing to be ridiculed, and willing to look up with a sense of childlike wonder, we might just find that we are not alone in the dark. The universe is ready to show us its secrets, but only if we are brave enough to open our eyes and really look. In the middle of our noisy world, where every phone notification demands immediate attention, and every rumour travels at the speed of light, there exists a sanctuary of slowness. It is a place that refuses to run. It is the quiet, deliberate world of the scientific process. To the outsider, this silence can feel frustrating. When we are scared or curious, we want answers now. We want the headline, the cure, or the confirmation within minutes. But to understand science is to understand that its silence is not empty. It is full of work. It is the sound of thinking, of checking, and of protecting the truth. Imagine a storm raging outside your window. The wind is howling, leaves are flying, and everyone is shouting over one another to be heard. That is the internet. That is the world of instant news. Now imagine walking into a thick-walled library or a stone temple. The noise fades away. The air is still. You can hear your own breath. This is the atmosphere of genuine research. It is here that the most important ritual of modern knowledge takes place, the process known as peer review. Peer review is often misunderstood as just paperwork or bureaucracy, but if we look at it with a sense of reverence, it is actually a ceremony. It is the firewall that stands between a random idea and a scientific fact. When a scientist discovers something new, perhaps a new medicine or a strange signal from a distant star, they do not run to a television camera. Instead, they write it down. They spend months crafting a manuscript detailing every single step they took. They write down the temperature in degrees Celsius, the exact weight in milligrams, and the specific methods they used. Then they submit this work to a journal and the silence begins. This is where the invisible guardians enter. The journal editor sends this work to other experts in the same field. These are the peers. They're often anonymous. They receive no money for this work. Their job is to try to break the discovery. They act like stress testers. They look for weak points. They ask difficult questions. Are you sure this calculation is correct? Did you consider that the temperature might have affected the result? Is there a chance this was just a coincidence? This back and forth can take months, sometimes even years. It is a slow, quiet conversation that happens behind closed doors. It is not secretive in a sinister way. It is private because it needs to be safe. It allows the scientists to be wrong without destroying their careers. It allows them to fix mistakes before the world sees them. It is a humble admission that no single human being is smart enough to see everything. We need each other to find the truth. In our modern era, we have forgotten the value of this waiting. When a new virus appears or a strange weather event happens, social media explodes with theories. People share videos and posts saying, "I heard this works," or "they are hiding the truth." The internet demands a verdict immediately. Meanwhile, the scientific community remains quiet. This silence feeds the conspiracy theories. People begin to whisper. They ask, why aren't they saying anything? They must be in an emergency meeting. They must be panicking. They are hiding the data to control us. The reality is far less dramatic and far more reassuring. When scientists go silent, it is usually because they are staring at a spreadsheet full of numbers. They are not debating how to hide aliens. They are debating whether a variation of 0.5% is statistically significant. They are not in a secret bunker. They are on a boring video call arguing about the calibration of a microscope. Those emergency meetings that people imagine are usually just groups of tired researchers drinking stale coffee trying to figure out why their data looks messy. Real science is rarely a Hollywood movie scene with flashing red lights. It is mostly quiet people thinking very hard. They are silent because they are terrified of being wrong. They know that if they speak too soon, if they announce a fact that turns out to be false, they could hurt people. They could destroy the public trust. So they wait. They check again, and then they check one more time. There is a beautiful humility in this slowness. In a world that rewards the loudest voice and the fastest tweet, science rewards the patient. It teaches us that the truth is not something you grab, it is something you build brick by brick. Think of a great cathedral or a historic temple. These structures were not built in a day or even a year. They were built over generations. The builders took their time to ensure that every stone was perfectly placed so that the structure would not collapse. Science is the cathedral of human understanding. Peer review is the inspection of each stone. If we rush it, the roof falls in on our heads. When we see a headline that says scientists are unsure, or when we hear that a study will take another 6 months to complete, we should not feel anxious. We should feel relieved. That delay is a sign that the system is working. It means they are not just guessing. It means they care enough about the truth to suffer through the boredom of verification. This process turns the raw, chaotic ore of human curiosity into the refined gold of knowledge. It filters out the impurities of bias, emotion, and error. It is a filter that catches the mistakes before they become dangerous. So the next time you encounter that silence from the scientific world, do not fill it with fear. Do not fill it with rumors, instead fill it with trust. Visualize a group of dedicated people sitting in a quiet room looking at data with deep focus. They are working for you. They are taking the time that you do not have to ensure that the medicine you take is safe, that the bridge you drive over is strong, and that the understanding we have of our universe is real. The silence of science is not the silence of a void, it is the silence of a seed growing underground. You cannot see it happening. You cannot rush it by shouting at the earth, but if you wait and if you trust the process, something strong and vital will eventually break through the surface. It is a slow, gentle and powerful rhythm that has guided humanity out of darkness and into the light, one carefully checked fact at a time. Let us honour that silence, for it is there that the future is being written. After surviving the inferno of the sun's atmosphere, the spacecraft does not stop to rest. It carries the heat of the star on its shield and the secrets of the corona in its memory banks, but its path is not a straight line. To touch the sun again, to dive even deeper next time, it must first look away. It must turn its back on the fire and drift outward into the cooling dark of the solar system. This is not a retreat, it is a calculated dance step. This is the beginning of the great cosmic waltz. As the calendar on Earth turns toward November, the probe sets its sights on a bright cloudy marble hanging in the black velvet of space Venus. This is the second partner in this intricate dance. For years, Venus has been the shepherd of this mission. The massive gravity of the planet acts like a giant hand grabbing the spacecraft and swinging it around. Imagine a dancer spinning their partner to change their direction and speed. That is exactly what happens here. The spacecraft approaches Venus not to land and not to stay, but to steal a little bit of energy. It flies purely on momentum. There are no roaring engines firing here, just the silent, invisible pull of gravity. As it skims past the cloud tops of Venus, the spacecraft slows down just enough to shrink its orbit, tightening the loop so that its next fall toward the sun will be even faster and closer. From the perspective of the probe, Venus is a beautiful, chaotic world. It is a planet of thick, crushing atmosphere and hidden volcanoes wrapped in layers of yellowish-white clouds. For a brief moment in November, the probe is a visitor in Venus's backyard. It measures the charged particles and the magnetic ripples near the planet, gathering bonus science data while it executes its turn. It is a graceful, silent flyby, a moment of elegance before the rush of speed takes over again. Once the encounter with Venus is complete, the trajectory shifts. The spacecraft is now slinging outward, moving on a long, curving path that will eventually bring it into alignment with the third planet, our home Earth. By December 2025, the spacecraft reaches a point in its orbit that brings it relatively close to Earth. It does not enter our atmosphere, nor does it come close enough to be caught by our gravity, but it swings by near enough to establish a strong high-speed data connection. This is a critical time. The data recorders on board are full of the treasures collected from the solar fire. Now across millions of kilometers of empty space, it begins to beam that information home. But this December approach offers something else, something rare and beautiful, a chance for a visual connection. On Earth, it is winter in the northern hemisphere. The nights are long, crisp and cold. The air is often dry and stable, providing a clear window into the depths of the universe. This season, the night sky is dominated by the brilliant constellation of Orion the Hunter and the sparkling cluster of the Seven Sisters. But this year, something else is hiding among the stars. For the scientific community, this is a time of downloading and decoding, but for the global community of amateur astronomers, this is a time of the hunt. A feeling of excitement spreads through online forums and local astronomy clubs. Coordinates are shared. Charts are drawn. The spacecraft is small, about the size of a car, and it is millions of kilometers away. It is not a blazing comet with a long tail, nor is it a bright planet like Jupiter. To the naked eye it is invisible, but to a telescope it is a target. All over the world, people step out into their backyards. They wear thick coats, gloves and scarves to protect against the December chill. You can see their breath puffing out in white clouds vanishing into the darkness, in quiet suburban gardens, on the rooftops of city apartment buildings, and in the dark fields of the countryside, thousands of tripods are set up. There is a unique magic in this moment. It connects people who will never meet. A teenager in Tokyo, a retired teacher in Berlin, and a family in California are all doing the exact same thing at the same time. They are adjusting the focus knobs on their telescopes. They are checking their star maps. They are looking for a needle in a haystack. They are looking for a tiny, faint dot of light moving against the background of fixed stars. Through the eyepiece of a backyard telescope, the Parker Solar Probe does not look like a machine. It looks like a star that has decided to go for a walk. It is a dim speck of light reflecting the sunlight off its thermal protection system, the very shield that saved it from burning up. Spotting it requires patience. It requires standing still in the freezing cold, waiting for your eyes to adjust to the dark. But when you finally find it, the feeling is overwhelming. You are looking at a man-made object that is currently holding the record for the fastest thing ever built by humans. You are looking at an explorer that has just returned from touching the face of the sun. You are standing on a frozen patch of grass, shivering in the winter air, looking at a machine that only weeks ago was enduring temperatures of over 1,000 degrees Celsius. The contrast is profound. Here on Earth, everything is still and silent. The only sound is the wind in the trees or the distant hum of traffic. But up there in that tiny point of light is a story of extreme violence and speed. That little dot is a survivor. For the amateur astronomers, this is a personal victory. Taking a picture of the moon is easy. The moon is big and bright. Taking a picture of the rings of Saturn is beautiful, but capturing the Parker Solar Probe is an act of connection. It is a way of saying we see you, we know where you have been. As the nights of December pass, the probe begins to fade. Its orbit carries it away from Earth once again, pulling it back toward the inner solar system for its next encounter. The dot of light becomes dimmer and dimmer until even the strongest backyard telescopes can no longer track it, but the feeling remains. For a few weeks, humanity looked up and saw their creation dancing among the stars. It was a reminder that we are not just inhabitants of a single rock. We are capable of reaching out and touching the fire that sustains us. The data has been delivered. The health checks are complete. The waltz with Earth is over. The spacecraft turns its antenna away from home and looks back toward the center of the system. The sun is waiting. The dance continues. The silence of deep space is deceptive. It feels empty, but as we approach the date of March 2026, the environment becomes thick with invisible forces. We are no longer coasting through the void. We are entering the throne room of the King of Planets. This is the moment we have been waiting for, the appointment with the giant. As the spacecraft, the Europa Clipper, closes the distance, the view out of the virtual window changes from a starry backdrop to something that defies human comprehension. Jupiter is not just a planet. It is a failed star, a swirling monster of hydrogen and helium that dominates the solar system. It hangs there in the darkness, a tapestry of violent storms, bands of burnt orange, cream and white all rotating with a speed that seems impossible for something of such immense size. The great red spot, a storm larger than our entire Earth, watches us like a giant unblinking eye. The emotion in the control room back on Earth and in the heart of anyone imagining this journey is a mixture of pure terror and absolute awe. We are small. We are incredibly small. The spacecraft, with its solar arrays stretching out like the wings of a great bird, is nothing more than a speck of dust compared to the gravity well it is falling into. And yet this speck of dust represents the absolute peak of human audacity. We are not fleeing from the giant. We are charging right at it. This is the celestial dance of gravity. We are not using engines to slow down or speed up in the traditional sense. We are using Jupiter itself. This is the gravity assist, a maneuver that feels like grabbing the hand of a spinning skater to fling yourself in a new direction. But the skater is a gas giant with a mass 300 times that of Earth. The math required to pull this off was calculated years ago, written in lines of code and equations, but now it is real. If the angle is wrong by even a fraction of a degree, the spacecraft could plunge into the crushing atmosphere or be thrown helplessly into the dark outer void. But the mission in March 2026 is not just about survival, it is about opportunity. As the Europa Clipper performs this death-defying loop around Jupiter, it finds itself in a unique position. We are not just looking at the planet, we are looking at what surrounds it. Jupiter is like a massive vacuum cleaner for the solar system. Its immense gravity pulls in everything: asteroids, comets, and drifting dust. For billions of years it has been capturing wanderers, and this leads to the most thrilling part of this specific encounter, the chance to intercept the tail of a comet. The scenario is breathtaking. A comet, perhaps a visitor from the distant Oort cloud, or even an interstellar object that wandered into our system, has recently passed close to Jupiter. As the sun heats this icy wanderer, it vents gas and dust, leaving a trail of debris behind it, a tail that lingers in space. Usually to sample a comet, we have to chase it for years across the solar system. But here, Jupiter's gravity has bent the comet's path, and our spacecraft is perfectly timed to fly right through the wake. It is a cosmic shortcut. Imagine the sensors on the Europa Clipper waking up. The dust analyzer, originally designed to taste the water plumes of the moon, Europa is suddenly repurposed for an even more exotic task. We are travelling at thousands of kilometres per hour, and we are about to fly through a stream of ancient particles. This is not just dust, this is history. These tiny grains of rock and ice are time capsules. They contain the raw materials from the birth of the solar system 4.5 billion years ago. Even more exciting is the possibility that some of this material is interstellar. This means it did not originate from our sun, but from another star entirely. It drifted across the vast empty ocean between stars and was caught by Jupiter's gravity net. The concept is mind-blowing. We do not need to build a warp drive to travel to Alpha Centauri to see what it is made of. The universe, through the power of Jupiter, has delivered a piece of Alpha Centauri right to our backyard. We are about to touch the material of an alien sun without ever leaving our own planetary neighbourhood. As the spacecraft punches through the tail, the data starts streaming back. It is a frantic high-speed download. We are looking for organic compounds, the building blocks of life. We are looking for water signatures. We are looking for minerals that simply should not exist in our part of space. Every impact of a dust grain on the sensor is a sentence in a story written by the galaxy itself. The visual grandeur of this moment cannot be overstated. To the left, the curvature of Jupiter fills the entire field of view, a wall of clouds stretching for thousands of kilometers. The radiation belts are singing with energy, a dangerous, invisible ocean that the spacecraft must navigate. To the right, the faint glittering stream of the comet's tail catches the distant sunlight. And in the center, our machine, a tiny ambassador from the third planet, performs its task with robotic precision. It creates a feeling of connection. We realize that our solar system is not a closed box. It is an open dynamic environment where planets interact with comets, where gravity sculpts the paths of objects, and where material from the deep universe flows through like a river. As the Europa Clipper completes the flyby, slinging past the giant and heading toward its primary target of the icy moon Europa, the significance of the March event settles in. We touched the giant, we survived its pull, and in doing so we snatched a handful of stardust from the air. This appointment with the giant was not just a technical necessity, it was a reminder of our place in the cosmos. We are the observers, the explorers who dare to sail close to the monsters in the dark, hoping to catch a whisper of the secrets they hold. And as Jupiter fades slightly in the rear camera, remaining a massive watchful guardian, we know that the data collected in these few precious hours will keep scientists busy for decades. We have looked into the eye of the king, and we have come away with treasure. When the data finally settled and the excitement of the chase began to fade, a quiet silence fell over the scientific community. The results were in, and they were undeniable. 3I Atlas was not a machine. It was not a spaceship. It was not a probe sent by a distant civilization to watch us. It was a rock. It was a dirty snowball, a mixture of ice and dust tumbling through the dark void. For many people watching the news, this felt like a disappointment. We have a deep human desire to not be alone. We want to find someone else out there, someone to talk to, or even someone to fear. When 3I Atlas turned out to be just a comet, the headlines called it a letdown. They said we had failed to find aliens. But this view misses the point entirely. In fact, discovering that 3I Atlas is a natural object is perhaps the most beautiful and important discovery we could have hoped for. To understand why this is so important, we have to look at what normality really means in space. If 3I Atlas had been a spaceship, it would have been a single event, a one-time anomaly. It would tell us that one specific civilization built one specific machine. But because 3I Atlas is a natural comet, it tells us something much bigger. It tells us about the general rules of the galaxy. It proves that the story of our own solar system is not unique. Think about a bakery. If you walk into a bakery in your hometown, you know how bread is made. You use flour, water, yeast, and heat. Now imagine you travel to the other side of the world to a country you have never visited. If you walk into a bakery there and find a loaf of bread that looks, smells, and tastes just like the bread at home, you learn something profound. You learn that the recipe for bread works everywhere. You do not need magic to make it, you just need the right ingredients and the right conditions. Atlas is that loaf of bread from the other side of the galaxy. By analysing the gas evaporating off the surface of 3I Atlas, scientists found things that were incredibly familiar. They found water ice, they found carbon monoxide, they found simple dust grains. These are the exact same building blocks that make up the comets in our own backyard. This is a massive realization. It means that the chemistry that created our Sun and our Earth is not a special miracle that only happened once. It is a universal standard. The water frozen inside 3I Atlas is the same as the water in our oceans. The carbon is the same carbon that makes up our bodies. This confirms that the ingredients for life are not rare. They are common. They are drifting everywhere between the stars, waiting for the right gravity to pull them together into a new world. This object also teaches us a wonderful lesson about how other solar systems are born. We know that when our solar system formed, it was a chaotic mess. Giant planets like Jupiter moved around, kicking smaller rocks and comets out into deep space. We have always assumed that other stars do the same thing, but we never had proof until now. 3I Atlas is that proof, is a piece of debris from a construction site light years away. It tells us that somewhere far away a star was born. Planets formed around it. And just like here, the gravity of those giant planets ejected trillions of small icy rocks into the dark. 3I Atlas is one of those exiles. It has travelled alone for millions of years, crossing the emptiness between stars only to pass by us for a brief moment. It connects our history to the history of a star we have never seen. It shows us that the chaotic, violent and creative process of planet formation is happening all across the universe. There is a deep comfort in this. If the universe were full of silence and nothing else, it would be lonely. If it were full of alien machines, it might be scary. But finding a natural comet means the universe is full of potential. It means that the galaxy is rich with the seeds of worlds. We must stop looking at the absence of aliens as a failure. When we look at a forest, we do not call it boring, because we do not see a person standing behind every tree. We appreciate the forest for what it is, a living, breathing ecosystem. The galaxy is an ecosystem of stars and dust. 3I Atlas reminds us that nature is the dominant force in the universe. The spectrum of light reflected off 3I Atlas showed us the colour red, very similar to the objects in our own Kuiper belt. This redness comes from organic molecules being hit by cosmic radiation over millions of years. Again, this is normal. This is expected. And that is why it is wonderful. It means the laws of physics do not change when you leave our solar system. Gravity works the same way there as it does here. Chemistry bonds atoms together in the same way. This consistency allows us to dream with accuracy. Because 3I Atlas is normal, we can look at a star in the night sky and be confident that it likely has comets, asteroids and planets made of the same stuff as ours. We are not an exception to the rule, we are part of the rule. There is a specific kind of majesty in the ordinary. A spaceship is something built with intent, but a comet is something born from the grand blind forces of the cosmos. 3I Atlas survived the cold of interstellar space. It survived the heat of its birth. It carries within it the frozen history of a place we will never visit. It is a time capsule. When we realized 3I Atlas was natural, the fear of an invasion vanished. The anxiety of being watched disappeared. What replaced it was a sense of kinship. We are made of star stuff, and so is this visitor. We are distinct, separated by unimaginable distances, yet we are made of the same fundamental clay. So as 3I Atlas begins its long journey back out into the darkness, leaving our sun behind forever, we should not feel disappointment. We should feel gratitude. It came to us to tell us that the universe is consistent. It came to tell us that the recipe for worlds is being cooked up in every corner of the galaxy. It did not bring us a message from an alien king or a warning from a galactic empire. It brought us something better. It brought us a mirror. It showed us that even across the terrified distances of space, nature remains true to itself. We found no little green men, but we found water. We found carbon. We found the dust that makes stars. We found that we are not isolated accidents, but part of a vast shared reality. And in that normality, in that simple frozen rock, there is enough wonder to last us a lifetime. The history of human astronomy can be divided into two distinct eras, the time before we knew and the time after we saw. For thousands of years, we looked up at the night sky and believed that our solar system was a closed room. We thought that the planets, comets and asteroids orbiting our sun were the only furniture in our house, isolated from the rest of the galaxy by vast empty darkness. We believed that nothing entered and nothing left. That era of isolation ended abruptly in October of 2017. When we look back now, we can see a clear lineage of discovery, a path of breadcrumbs that led us to this moment of understanding. It began with Oumuamua. It was the first shock to our system. It was small, fast, and incredibly strange. It tumbled through space like a piece of driftwood, caught in a violent current. It moved with a speed what scientists call hyperbolic excess velocity, that proved mathematically it could not have been born around our sun. It was a visitor. Oumuamua was the first messenger. It teased us. It arrived before we already zipped past the sun and began its journey back into the deep black before we could get a good look at it. It left us with more questions than answers. Was it a rock? Was it a chunk of ice covered in organic dust? Was it as some dared to dream technology? It woke us up. It forced us to realize that the space between stars is not empty. It is a busy highway, and we had just been too blind to notice the traffic. Then, just 2 years later, came Borisov. If Oumuamua was the mysterious stranger, Borisov was the reassuring confirmation. It looked familiar. It had a tail of gas and dust behaving exactly like the comets we know in our own system, yet its path proved it was an alien. Borisov told us that other stars have solar systems very much like our own building. Comets from the same building blocks of water and carbon. It made the galaxy feel a little less alien and a little more connected. And now we have Atlas. This object represents the third step in our education. While the first two were just passing through, speeding by on one-way trips to Infinity, Atlas showed us a different possibility. It hinted that some of these interstellar wanderers might get trapped. It showed us that our solar system acts like a giant fishing net, occasionally catching these damned travelers and keeping them here for us to study. We realized that alien objects aren't just flying past us. Some of them might be hiding among us, disguised as regular asteroids waiting to be found. This trilogy of discovery, from the shock of Oumuamua to the confirmation of Borisov and the complexity of Atlas, marked the end of our childhood in the cosmos. But the most exciting chapter is not about what we have already seen. It is about the machine that is waking up right now to show us the rest. We are standing at the dawn of the era of the Vera C. Rubin Observatory. Perched high on a mountain peak in Chile, this telescope is not just another scientific instrument. It is a revolution. In the past, finding an interstellar object was like finding a needle in a haystack while searching in the dark with a tiny flashlight. We found Oumuamua and the others mostly by luck. We happened to be looking at the right spot at the right time. The Rubin Observatory changes the game entirely. It is a wide-angle camera of immense power. It does not just look at small patches of the sky. It scans the entire visible southern sky every few nights. It creates a movie of the universe. It records everything that moves, everything that changes brightness, and everything that appears where nothing was before. For decades, astronomers predicted that there must be millions of interstellar objects passing through our solar system at any given moment. They calculated that the sky should be full of them. The problem was that they were too faint and too fast for our old eyes to see. The Rubin Observatory gives us new eyes. We are moving from a time of scarcity to a time of abundance. In the near future, discovering an object like Oumuamua will not be a breaking news event that stops the world. It will become routine. Scientists estimate that once the Rubin Observatory is fully operational and the algorithms are tuned, we could detect dozens of these interstellar visitors every single year. Imagine that shift in perspective. We are going from seeing one visitor every few decades to seeing one every few weeks. This transition changes the very nature of astronomy. We are moving from a phase of discovery to a phase of statistics and characterization. We will no longer ask, are they out there? Instead, we will ask, what are they made of? Where did this specific one come from? How long has it been traveling? We will begin to categorize them. We will find rocky metallic worlds ejected from dying stars. We will find fluffy, icy snowballs thrown out of young, forming solar systems. We might even find objects that challenge our definition of what is natural. We will be able to create a map of the galaxy not just by looking at distant stars, but by studying the debris those stars have thrown at our doorstep. This shift signifies a profound maturity for our civilization. A child fears the dark because they do not know what is in it. An adult turns on the light and takes inventory of the room. For all of human history, we were the child. We huddled around our sun, unaware of the cosmic context we lived in. Now we are turning on the lights. We are realizing that our solar system is not a hermetically sealed bubble. It is an open system. It breathes in material from the galaxy. Rocks from other stars crash into our planets. Dust from other worlds sprinkles down into our atmosphere. We are constantly exchanging matter with our neighbors. There is a beautiful, hopeful feeling in this realization. It means we are not isolated. The carbon, the water, and the silicate in these objects are the same materials that make up our bodies and our Earth. When we spot a new object entering our system detected by the automated alerts of the Rubin Observatory, we will not look at it with fear. We will look at it with the excitement of a biologist finding a new species or a geologist finding a rare gem. We have graduated. We have moved from the chaotic surprise of the unknown to the calm confidence of routine observation. The universe is vast, yes, but it is becoming familiar. We are ready to catalogue the stars one drifting rock at a time. The door is open, the telescope is focused, and we are finally ready to see who or what is coming to visit. And now we have reached the end of the journey. We have watched the drama unfold near the sun, but now the theatre is emptying. The lights are dimming. The show is over. Look out into the deep velvet blackness of space one last time. Can you see it? It is very hard to see now. Comet 3. Atlas is no longer that bright, angry scar across the sky. It is no longer a burning torch. It is fading. It is shrinking. It is becoming a ghost. Slowly, very slowly, the great tail of dust and gas is disappearing. The wind from the sun can no longer reach it. The heat that made the comet sing and scream is fading away. The ice is freezing over again. The surface, which was cracking and shifting, is now becoming still. The heartbeat of the comet is slowing down, slower, slower, until it matches the silence of the void. It is moving away from us. It is drifting back into the shadows. It is heading toward the edge of the solar system, a place so far away that the sun looks like just another bright star in the sky. It is going to a place where the temperature drops to near absolute zero, almost minus 270 degrees Celsius. It is a place of perfect preservation, a place of eternal ice. As it fades, we realize that this is not just a temporary goodbye. This is a farewell that will last forever. The path of this comet is not a closed circle. It is an open line. The gravity of the planets and the sun has given it a final push, a gentle nudge that will send it drifting out of our solar system entirely. It will never return. Think about that for a moment. The object we watched, the object we studied, is leaving us. It will travel for thousands of years, then millions of years, drifting through the emptiness between the stars. It will float alone in the dark, a silent traveller, carrying the secrets of its creation, never to be seen by human eyes again. There is a beautiful sadness in this. It is a melancholy feeling, like watching a ship sail over the horizon, knowing it will never come back to port. But it is also peaceful. The struggle is over. The danger is past. The comet survived its brush with the fire, and now it has earned its rest. It is returning to the long, dreamless sleep of the cosmos. So what do we take away from this brief encounter? What did this lonely traveller teach us before it vanished? It taught us the balance of nature. It showed us that beauty often comes from chaos. But most importantly, it taught us the lesson we spoke of before. Stay curious, but keep a cool head. We humans are like the comet in some ways. We are drawn to the light. We are drawn to the heat. We want to know everything, see everything, and feel everything. We have a burning curiosity that drives us forward. That is a good thing. That is what makes us explore. That is what makes us look up at the night sky and wonder, what is that? But the comet also showed us the danger of getting too close. If 3i Atlas had flown just a little closer to the sun, it would have evaporated completely. It would have been destroyed by the very thing it was reacting to. The lesson is to observe the fire without touching it, to love the mystery without being consumed by it. We can marvel at the universe, we can study the stars, and we can feel deep emotions, but we must always maintain a sense of calm. We must keep our perspective. We must find the quiet center within ourselves, just as the comet finds the quiet dark of space. Warmth is good, but the cool air is where we find clarity. Passion is good, but peace is where we find rest. Now imagine the comet is just a tiny speck of light millions of kilometers away. It is so small now. It is smaller than a grain of sand held at arm's length. And then it is gone. It has slipped behind the curtain of the night. It has merged with the darkness. The sky is empty again. The stars remain steady and unblinking. The universe continues its slow, majestic dance, indifferent to the coming and going of one small rock. It is time to let it go. Send a thought out into the darkness. Send a wish to that lonely rock. Whisper it in your mind, goodbye, traveller. Journey well. May your sleep be long and undisturbed. You are a beautiful visitor, and we will remember you. And as you say goodbye to the comet, it is time to say goodbye to the day. The world around you is quieting down. The noise of the traffic, the hum of the city, the worries of work and life, they are all drifting away just like the comet. They are moving further and further into the distance until they are too small to see. You are safe here. You are in your own orbit. You are wrapped in warmth, protected from the cold vacuum of space. The gravity of the Earth holds you gently. You do not need to rush anywhere. You do not need to burn bright right now. You only need to rest. Let your breathing become slow and steady, in and out, like the slow orbit of a planet. Think of the cool darkness, not a scary darkness, but a velvet darkness. A soft blanket that covers the world and allows it to recharge. The comet has found its peace in the shadows, and now you can find yours. Close your eyes if you haven't already. Picture that vast empty space. It is silent. It is still. There is no sound there, no wind, no friction, just perfect weightless floating. Imagine yourself floating like that, weightless, drifting. No effort is needed. You are just suspended in the soft, quiet night. The story of 3i Atlas is finished. The book is closed, the telescope is capped, the data is saved. Everything is exactly where it needs to be. There is nothing left to solve tonight. There is nothing left to figure out. Your curiosity has been fed, your mind has been active. Now it is time for the cool head. It is time for the brain to cool down, to settle, to stop spinning. Let the quiet wash over you. Let the stillness settle in your chest. To the lonely comet drifting into eternity, safe travels. To the stars watching over us, thank you for your light. And to you, the listener lying there in the safety of your room, good night. Let the darkness hold you. Let the silence soothe you. Sleep well and drift into your own beautiful dreams.